Next situation we're going to get, this is a tricky one, because you're going to have one situation, and depending on the way the question is worded, you're going to have two possible ways of doing it. So let's just take our situation here. We're going to have, again, our block. We're going to have our block being, this time we'll use 700 newtons. We'll have it being applied at 17 degrees. Again, we don't care what the mass is. And this time though, we're going to have a force of friction opposing at 250 newtons. And we're going to cause it to move 30 meters. So we're going to have it end up right here. Now I guess we would care what the mass is if you weren't given the value of friction. If you were just given the coefficient of friction, you had to do a calculation. Well, that question gets really tough because we have a normal force that we have to watch out for and we need to know the mass. But in this case, this is all we're given. So now if we're going to do the work done on the object then is this mass, and all we do is look at it purely from a physics point of view of what's happening here. So this is work done on. Okay, so if it's the done on, then all we do is we go work equals F net times distance. Same formula. Our F net is going to be 700 cosine of 17 degrees, but we have to subtract off this 250. We're going to times all of this by 30. Okay, so when we do this, we get 669 subtract 250 and times that by 30, and in the end you end up getting 12582 joules. Okay, that's the work done to the object. This mass moving here to here is going to require this much energy being transferred to it to cause it to move. That's done on. I don't really need much space to do the done by, because now it's going to be looked at from a totally different point of view. What we're going to think of it now is not in terms of what the mass does to move from here to here. The mass still moves from here to here, but now the question is, you did the moving. So how much energy did it cost you to actually move from here to here? Your formula is the same. F equals F net times distance. Everything ends up being the same numbers, so it's still going to be 700 cosine of 17 degrees, but this time we have to add our forces. When friction is involved and you're pulling on this object, it's harder to do. You have to fight against friction. So the energy that you expend should actually increase, not decrease, like here. Okay, so we add them. Now that ends up giving us a value of 919 when everything is said and done, times 30. So the total work done, 27,570 joules. And that's the work done by you to cause this to move from there to there. So now this really has nothing to do with the mass or F nets. This just has to do with totals. So maybe I shouldn't put F net because that suggests subtraction. Maybe I should have put F total here, which would more along the lines be the addition. So there you go. That's a tricky question. Lots of distinctions that need to be made.